Hello Year 9, here's another starter for you for Tuesday's lesson. We did it the other way around yesterday, so just see if you can write these mixed numbers as top-heavy fractions. I've done an example here for you. 2 whole ones, each whole one you can break into 3/3, so that's 6/3 with an extra third gives you 7/3. Pause and have a go at the others. Okay, so here's my very rubbishy little drawing. So 4½. So here's 4 whole cakes split into halves. So that's 1, 2, 3, 4, 5, 6, 7, 8 bits. Plus the extra half is 9 halves. 1 3/4. So it's the denominator here that tells us what fraction we're dealing with quarters. So my 1 whole one I need to split into quarters. An extra 3/4 gives me 7/4. You might be pleased to hear I'm going to stop trying to draw pictures now. So I'm dealing with thirds now. So 1 whole cake would be 3/3 plus another couple gives me 5/3. Here I'm dealing with fifths. They're called fifths because if you take a cake and cut it into fifths, you get 5 pieces. Plus another 2, that's 7/5. 3½, well, it's like this without that one. So that's 7 halves. And fifths again, so a whole cake, if you cut it up, will give you 5/5. I've got 2 whole cakes, so that would be 10/5 plus 4 is 14/5. Well done. If you got those, we'll perhaps do a few more of those starters along the way. Let's move on to the lesson proper. Okay, so to start with today, I want to talk about fractions and decimals. I'm hoping I can bring it round full circle to include percentages at the end. And I'm going to rush through this because, again, as with many of these introductory things, I'm fairly sure you're okay with them. I've got some decimals here. There are 3 sorts of decimals. There are decimals with 1 decimal place, 2 decimal places, and 3 decimal places. And converting these back to fractions are really easy. So we talked about this the other day. This here is called the tenths column. So that's 3/10. Similarly, this would be 6/10. The only difference with this one is that I should then really cancel that fraction down. Divide the top and the bottom by 2 in this case. This here is the hundredths column, so I've got 1/10 and 7/100ths, or 17/100ths. So as a fraction, that's 17/100ths. Can't cancel that one down, but similarly I should always check to see if I can cancel down. And then I've got 1/10, 2/100ths and 3/1000ths, or 123/1000ths. So as a fraction, that looks like that. And anything that goes into the 3rd decimal place is going to be in thousandths. So this is 85/1000ths. That one I can cancel down. 85 is in the 5 times table. It's 17 times 5. And how many 5s in 1000? There are 200 5s in 1000. So I'm hoping this exercise won't take you very long at all. Just write them as fractions for me and then just check if you can cancel them down. Pause and have a go. Okay, so my tenths, all okay, and this one I could simplify. None of my hundredths could be simplified, so they just stayed as fractions over 100. My thousandths, well, that one I could divide top and bottom by 4. That one I couldn't simplify. That one I couldn't simplify. This was a tricky one. I'm impressed if you got that right. You could halve top and bottom. So going from a decimal to a fraction is really straightforward. So what about when we go from a fraction to a decimal? Let's have a look at that. In yesterday's lesson, we changed fractions to percentages by making their denominators 100. And it's very similar, isn't it? Changing fractions to decimals, except it's easier. We can change it if we can get a denominator of 10 or a denominator of 100 or a denominator of 1000. We've just shown in the previous exercise that it's easy if you've got fractions written with any one of those denominators. So we don't just aim for a denominator of 100, we could aim for 10, 100 or 1000. Let's have a look at a couple of examples. So 4/5, I can easily change that to have a denominator of 10 by doubling it. So I double the top as well, and therefore I know that is 0.8, 8/10. Here, I can also go for a denominator of 10, can't I? This time, because they're both in the 3 times table, I can divide them both by 3. 30 divided by 3 is 10, 15 divided by 3 is 5, so that's a half. You might have spotted it as a half anyway, but it's 5/10, 0.5. Here I can go for a denominator of 100, because 4 times 25 is 100. So I multiply the top by 4 as well. So as a decimal, remember we're not going for percentages, we're going for decimals, 0.28. Here I can also go for 100, even though it's bigger than 100, because I can divide it by 2, and therefore I need to divide the top by 2 as well. So that's 7/100, that's 0.07. Here I can't get that down to 100, I'd have to divide it by 5, and 9 you can't divide by 5, but I can get it to 1000 by doubling it. So that's 0.018, 18 thousandths. So we're doing this in reverse. We know if we've got a fraction with 10 as a denominator, it's going to be in tenths. 100, it's going to be hundredths. 1000, it's going to be thousandths. So if we can get a fraction to have a denominator of 10, either by multiplying or dividing, easy to write it as a decimal. If we can get a fraction to have a denominator of 100, either by multiplying or dividing, easy, and similarly for 1000. So I think it might take you a little bit longer. Have a go at that set of questions. You've got to change them to decimals and do it by changing the denominator to either 10, 100 or 1000 first. Remember, you can multiply or you can divide. So I'd like you to write those as decimals for me. Press pause and have a go. This was tricky. So this I changed to a denominator of 10, so it was 2/10. This I changed to a denominator of 10, so it was 2/10. This one I did two ways. Firstly, I changed it to a denominator of 100, giving me 0.90. I then spotted that actually I could have changed it to a denominator of 10 by dividing it by 5. That would have been 9/10, 0.9. Hopefully you can see this is the same, and unless we're writing money, we don't need that extra 0. It doesn't actually change. It's not wrong, but we just don't need to write it. That I changed to 10 as well. The eagle-eyed amongst you would have realised that the first question you could change them all to 10, even though I did that to 100. The second question they all went to 100. So I doubled numerator and denominator, 0.34, multiplied by 4, 0.88, multiplied by 2, 0.86, divided by 3. Did you spot that one? Well done if you did, 0.32. Last question, they were all 1000, doubled, so that's 0.002. Multiplied by 4, 132 is 33 times 4, so that's 0.132. Multiplied by 5, and again, did you spot that? Dividing by 3. Now some of you will be saying, okay, again, you are only choosing fractions with nice, easy denominators that I can change to 10, 100 or 1000. And you're right. There's a second lesson in this sequence which looks at how we can convert more complicated fractions to decimals. The good news is that part of that is done on the calculator. And there's also a manual way that uses the bus stop division method. So that's going to be next lesson. Anyway, I want to now link what we've done with yesterday's lesson on percentages. Now, why, when we're doing a topic on fractions, am I talking about decimals and percentages? Well, we are partway through converting fractions to decimals, and last lesson we converted fractions to percentages. So if we can convert decimals to percentages, then we've got the full loop completed. And I'm sure you're going to find this really straightforward. I'm sure this is nothing new. Just a reminder that a decimal, like 0.23, is 23%. This is 23 hundredths. That's 23 hundredths. This is 7%. Percentages, 0.12, 12 hundredths, so that's, sorry, 12% is 0.12. 8%, you've got to be slightly careful, haven't you? That's 8 hundredths, so it's not 8 tenths, it's 8 hundredths. That's a particularly important one to make a note of. And 8.5 looks like that. No double decimal point in that. And the more eagle-eyed amongst you will realise that converting decimal to percentage is simply a case of multiplying it by 100. 0.23 times 100 is 23. And obviously, therefore, the reverse is to go from percentage to decimal, you divide by 100. Now, I suspect you won't need to think about that. I suspect most of you will just look at that and say, I know that's 0.12. You won't have to think about dividing by 100. But if you get one that you're stuck on, maybe like this, just think, what would I get if I divided that by 100? Okay, can you fill in the blanks here for me? We've got 4 percentages missing and 3 decimals missing. Just see if you can do that for me. Thank you. Pause and have a go. Okay, so hopefully you were okay there. And if you think of that as 0.70, hopefully we're able to see it at 70%, or if you were stuck, just multiply it by 100. Do 0.7 times 100, you get 70. 0.17 is 17. 0.025, again, might be able to do it in your head. That's 2%, so it's going to be 2.5%, or multiply it by 100. What do you get if you multiply that by 100? Move it up 2 columns, you get 2.5. Going the other way, 13%, 0.13. 40%, 0.40, but remember we don't really need that extra 0, so it's 0.4, a bit like up here, 0.7 was 70, and I'm hoping I didn't catch you out there, 0.04 for 4%, so it's important that you see the difference. 40%, 0.4 or 0.40, 4%, 0.04. If it helps you to put the full 0 in, do it, there's nothing wrong with that. So here's our a little activity for us. In this grid here, there are equivalent quantities in pairs, and then there's an odd one out. So we've got to identify the pairs and identify the poor odd one out. And we've got a mixture of fractions, decimals, percentages. So I think the easiest way is to write them all in the same form. We could write them all as percentages, we could write them all as decimals, we could write them all as fractions. I'm going to go for decimals, and I'm going to write them all as 2 decimal place decimals. I haven't got any thousandths to worry about here, and I know that when I'm comparing decimals, it's easier if they've all got the same number of decimal places. So I know that 0.4 is 0.40, 50% is 0.5, so I wouldn't normally write it as 0.50, but I am in this case because I want to compare it. 13%, 0.13. 4%, 0.04, a quarter, so that is, can't turn it into 10, but I can turn it into 100 by multiplying it by 25, so that's 25%, 0.25, and you should have already known that really, shouldn't you? A quarter is 0.25. 40%, 0.40, 25%, sorry, 0.25 already written as a 2 decimal place decimal. That's 0.13, 13 hundredths, and a half is 0.5, isn't it? And I'm going to write it, I wouldn't normally do this, but because I'm comparing, I'm going to write it as a 2 decimal place number. Right, okay, can we pair them up? Yes, we can. Look, 0.5, 0.5, so 50% is the same as a half. I'm sure you would have known that anyway. 0.4 and 40%. 13% and 13 over 100, 0.25 and a quarter, so the odd one out is poor old Mr. 4%. Okay, can I get you to have a go at doing that for B? I'm going to go through the answer to B in a minute. Pause and have a go. Now I know I'm sort of breaking a lot of the rules I've talked about. I know I'd say this is 1/10, 0.1, you don't need the extra 0, but when I'm comparing, it's always helpful if you've got the same number of decimal points, so that's why I've written it as 0.10. And similarly 10%, I would normally just write that as 0.1, but I'm leaving it as 0.10. Same with 3/10, 0.3, but because I'm comparing, I'm writing it as 0.30. So hopefully you were able to then pair them up. So I've got 0.3 and 3/10. I've got 3/4 and 75%. You could probably pair that one up without having to do any decimal work at all. 2% and 0.02. 10% and 1/10. So there's my poor little odd one out. Okay, so you can probably guess what's coming now. I'd like you to do C and submit that as your answer for today's lesson. So just a photo of it, and I look forward to seeing that, and hopefully you will have found that okay. Add a comment in your submission to say, I went too fast, this is all too easy, whatever if you want to give me some feedback along those lines, that's really, really helpful. So tomorrow we're going to look at harder fraction to decimal conversion, where the denominator isn't a nice, easy denominator, will convert nicely into 10, 100 or 1000. Take care.